welcome back to Algebra 1. Our goal for today is to continue working with our solving equations and inequalities. And more specifically today, can I solve when it takes two inverse operations when we have an inequality? At this point, I should fully understand that an equation is a mathematical statement that it contains an equal sign and will always be in the format of an expression, an equal sign, and an expression. Our inequalities, which we're going to add back in today, are in that same format of two expressions, but in between them must be one of our four inequality symbols: a greater than, a less than, a greater than or equal to, or a less than or equal to symbol. Since these problems have an infinite amount of solutions or a series of solutions, when we're done solving, we typically make a picture graph version to show that set of solutions. It's a little bit different than our equations, because when we're done solving our equations, we'd get an individual point or a dot on our number line. So we don't tend to normally show it in a picture version, where with the inequalities we tend to want to show, here's the set of solutions for this particular inequality. So our goal for today, if it takes two inverse operations to help us solve when we have an inequality start. Please remember, the only thing that's different today from our previous learning with two-step equations is our flip, no flip rule. So whenever I'm using my inverse operation, multiply or divide, if I multiply or divide by a negative, I have to flip-flop the direction of the inequality to get the correct answer statement and end up with the correct picture of this correct solution. So be careful. Everything else is going to be identical to what we've been doing for the last few days with our solving equations. So hit pause here, fill in your blanks, how we go about solving two-step inequalities. All right, it's still going to take us two inverse operations to help us solve here. We're still working through PEMDAS backwards for our order. So if the original is an add, we'll subtract. If the original is a subtraction, we'll add. We're always looking for one of these two, one of those two first. All right, we look for those guys, the adds and subtracts first. And then we look for our multiply and divides second. And when you get down here to your multiplies and divides, you also have to think about flip, no flip. So there's quite a bit going on here that you have to remember during your solving process. Once you're done solving, if your answer statement is not in variable first order, I would take the time to switch the variable to the front, the number to the back, and flip-flop the direction of the sign so that you know where you should be shading for your solutions. Because if we have a letter is bigger than something, we'll have an open circle and we should be shading to the right. If we have our variables less than something, we'll have an open circle and we should be shading to the left. If we have a greater than or equal to, we'll have a closed-in circle and our solution should shade to the right. And if we have a less than or equal to, we'll have a closed-in circle and we'll end up down here where we'd be shading to the left. All right, let's look at some examples. Number one, we want to solve for the variable w here when we're told w divided by -2 plus 3 is less than -5. I would still start with a box here. That would be my suggestion. I would cover my entire w term, which is that entire fraction. And what we can still see inside of our box is the adding part we have to remove first. We need to remove that add 3 first. We have w divided by -2. We're adding 3. Our inverse would be to subtract 3. When adding and subtracting, we never flip anything. So this less than is coming down the way that it looks. And we have a -5, and we're subtracting 3 from it. All right, cancel on the one side. We'll get w divided by -2 is less than -5 minus 3 would just give us a -8. All right, our next step will be our multiply divide step. Whenever we're doing our multiply divide step, we have to check to see if it's a flip or no flip. So be careful. So our next step is we need to remove a divide by -2. So we have our w divided by -2. Since it's a divide, we're going to multiply. Whatever number we put right here is our number that determines whether it's a flip or no flip. So if that number is a positive number, no flip. If that number is a negative number, we have to flip on this step the direction of our sign. So since this is going to be a -2, on the same step, we have to flip this to a greater than. And there's a bunch of us flipping, but not until our answer statement, which would cause this step to actually be incorrect. So be careful. All right, what we do to one side, we got to do the other. So over here with our -8, we also have to multiply by -2. All right, over here with W, we're going to cross cancel, leaving us with W is every number greater than 16. All right, since there's an infinite amount of solutions, we're going to make a picture version of all those solutions. So 16 in the middle, 15 and 14 getting smaller. Make sure you're numbering your number line correctly. You're not just filling in random numbers there. As we go left, we get smaller. As we go right, we're getting bigger. All right, open circle at 16, and we should be shading things greater than 17, 18, 19, 20, 21, and so on until we get to positive infinity. All right, number 2. I want to solve for 3m minus 7 is greater than or equal to -4 for the variable m. Again, our variable m is here in front of our greater than or equal to symbol, so that's the side we want to focus on. I'm going to cover my entire term that has m. What I can still see in my box would be a subtract 7. That's what we need to do the inverse of first by adding 7 to both sides. So we have a 3m minus 7. We're going to add 7. Bring down your greater than or equal to. What we do to one side, we got to do the other. So over here with our -4, we also have to add 7. All right, on our left side, the 7s are going to cancel, leaving us with a 3m. Over here, a -4 plus 7 would just give us a positive 3. All right, our next step is going to be looking for multiplication and division. That's when I have to check to see it's a flip, no flip, so be careful. So since this is a multiply right now, our inverse operation would be to divide. Whatever number we put here, right, that's our one we're dividing by. That's our flip, no flip number. If it's a positive, no flip. If it's a negative, on this step, we have to flip the greater than or equal to a less than or equal to, so be careful. So since this is going to be a positive 3, this sign does not flip. It's going to stay as greater than or equal to. All right, what we did on one side, we got to do the other. So over here, we also have to divide by 3. All right, cancel on our side with m. We get m is every number greater than or equal to 1. All right, since there's an infinite amount of solutions here, we want to make a picture version of all of those solutions. So 1 in the middle, 2 and 3 would be getting bigger, 0 and -1 would be getting smaller. At 1, we'd have a closed-in circle here. It can be equal to 1. So remember, our rule from our previous lessons is if it's a solution, we color it. So 1 is a solution, right? We could say, is 1 bigger than or equal to 1? Sure is. It's equal to. That works. And then we need everything. That gives our equal to part. So now we have to shade all the greater than part. So towards 2, 3, 4, 5, 6, 7, all the way to positive infinity are the rest of our solutions. All right, number 3, we want to solve for the variable e when we're told e divided by -9 minus 3 is less than -3. All right, again, our variable e is here in front of our less than sign. That's the side we're going to focus on. If I cover the entire term that has e, which is the entire fraction, what I can still see inside that box is what I need to get rid of first, because it's going to be this add, subtract part of the problem. So we need to get rid of that subtracting 3 by adding 3 to both sides. Adding and subtracting never flips anything, so this is going to stay as a less than. All right, cancel on the one side, bring down our e divided by -9 is less than. -3 plus 3 is just a value of 0. All right, our next step is going to be our multiply divide inverse operation, where we have to check to see if on that step we are going to flip or no flip. So in this case, we need to remove a divide by -9, which means we're going to multiply. And the number we multiply by is our flip no flip number. So since this number we're multiplying is a -9, that means on this next step, this has to change to a greater than to make sure that from that point on, we have our correct solution. So be careful. And so we would have a 0 times -9 also. All right, cross cancel. We're left with e is every number greater than 0. Be careful if I forget to flip here. 2 steps would be wrong, and then everything I do on my number line to graph the solutions would be wrong, so be careful. 0 in the middle, -1 and -2 getting smaller, and 1 and 2 would be getting bigger. All right, since it's just a greater than open circle, because 0 is not a solution, right? It can't be equal to 0, so I leave it open. It's just a starting spot. And then we have to shade in everything greater than that 0. So I'm heading towards 1, 2, 3, 4, 5, all the way to positive infinity. So I need this arrow that says these solutions go on forever here. All right, number 4. 3x minus 2 is less than or equal to 4. Again, our variable x is here in front of our inequality sign, so it's the side we want to focus on. I take my hand, my thumb, my pinky, something, I cover up the 3x term. What I can still see in that box of subtract 2 is this add, subtract part I always have to get rid of first. So we need to do the inverse of subtracting 2, which is to add 2 to both sides. Adding and subtracting never flip-flops anything with our sign, so leave it as a less than or equal to for now. All right, cancel our 2's, bring down our 3x is less than or equal to 6. All right, our very next step is going to be this multiply divide step where I have to check to see on that step is my sign going to flip or not flip. So this is a multiply right now. We have 3 times x, which means we need to divide. And more importantly, in this case, we have to divide by positive 3. Since this 3 right here that I'm writing is a positive, this does not flip. It stays as less than or equal to. I bring down our 6, divide by 3. Cancel on the one side, get x is every number less than or equal to 2. All right, since there are infinite amount of solutions, let's make a picture version of what they look like. So 2 in the middle, 1 and 0 getting smaller, 3 and 4 getting bigger. Since it could be equal to 2, my starting circle has to be colored in. Right? If it's a solution, we color it. So if it's equal to 2 here, we have to color it in. And then we also have to count that x could also be everything less than 2. So I want to start heading towards 1, 0, -1, -2, -3, all the way to negative infinity. So you need an arrow there on the end to say these solutions go on infinitely or on forever. All right, last couple are going to require a distribute before we get to our 2 inverse operations. So the only thing different here, remember, is we have to remove our parentheses before we start that process of working through PEMDAS backwards. So right now we have a 4 times that has to get sheared to our 3w and our minus 5. So 4 times 3w would give us a 12w. And 4 times negative 5, be careful there, is a negative or subtract 20. Bring down your less than 4. All right, once we get here, I want a box, cover up my term with w, and what I can still see is my add or subtract part I have to get rid of first. We need to get rid of the subtracting 20 first by adding 20 to both sides. Adding and subtracting never flips anything, so this is going to stay as a less than. All right, cancel on the one side, bring down our 12w is less than. 4 plus 20 would just give us a value of 24. All right, our next step will be this multiply divide step where I have to check to see if it's a flip or no flip. So be careful. So we got divide here. And the number we're going to divide by is our flip, no flip number. So the number I put here in the denominator, this positive 12 is the one that will determine if it flips or not. Since it's a positive 12, no flip, this stays as less than, and I continue to solve using my inverse operations from there. All right, I cancel here. I get w is every number less than positive 2. All right, since there are an infinite amount of solutions, let's make a picture of what they would look like. 2 in the middle, 1 and 0 getting smaller, 3 and 4 getting bigger. Add 2. It's not a solution. It can't be equal, right? There's no little bar here saying 2 is a solution, so we leave it open. And then we want to show that w could be everything less than that value of 2. I'm going to start heading towards smaller things. 1, 0, -1, -2, -3, all the way to negative infinity. And we show that with that arrow at the end. All right, number 6, we need to do a distribute and then use our inverse operations to help us solve from here. So we need to get rid of these parentheses by taking our outside item of 8 and expanding or distributing it to the 8 or to the h and the plus 4. This 8 is less than or equal to, we'll just stay there for now. All right, 8 times, remember, this is a 1h. So 8 times 1h will just give us an 8h. And 8 times 4, bring down our plus, it's still a positive. In this case, we should have a positive 32. All right, once we get here, my suggestion box, your H is behind the inequality symbol. So as we solve, it's going to stay in the back or behind that inequality symbol. So be careful. If I cover the HH, what I can still see in there is plus 32. That's this add subtract part I have to remove first. We have to start with the inverse of adding 32, which means on both sides we should be subtracting 32. So with our expression of 8, we're going to subtract 32. Bring down our less than or equal to. With our expression of 8h plus 32, we have to subtract 32. Adding and subtracting does not ever flip our sign, so it's staying as the less than or equal to. All right, they're going to cancel over here on our side with 8h. Over there, 8 minus 32. Combine those like terms, we'll have a negative 24. All right, our next inverse operation is going to be our multiply and divide step where I have to check to see if it's a flip, no flip problem. So in this case, we need to remove a times by 8, which is going to mean I take my both expressions and I'm going to divide them by 8. Since the number I'm dividing by is positive 8, no flip. This is going to stay as less than or equal to. All right, cancel on the side with H. On the other side, do your divide. Negative 24 divided by an 8 would give us negative 3 is less than or equal to H. Good fun. All right, since there's infinite solutions, let's go ahead and grab. So negative 3, negative 4, negative 5 getting smaller, negative 2, and negative 1 getting bigger. All right, since negative 3 can be a solution, when we start here with our circle, it needs to be colored in or what's called a closed-in circle. All right, if negative 3 is less than h, that means h is actually greater than negative 3. So our solutions here should go towards negative 2, then negative 1, then 0, then 1, then 2, then 3, then 4, and so on, all the way to positive infinity. Now, if your gut told you to shade to the left here because of that symbol, then off to the side, you want to put the letter in the front, the number in the back, and flip-flop your sign to help you remember we should be shading the solutions over here. It's not a step, but some of you rely on that. Put the variable in the front before I know where to shade version, so be careful. All right, last one for today. I have negative 20 is greater than or equal to 5 times 3 minus d. Since there's grouping symbols or parentheses in this problem to start, we have to start by removing them by using the distributive property. Once they're removed, we'll be back to a two-step problem. We need to take this 5 times and share it with the 3 and the negative d. Bring everything else down. So negative 20 is greater than or equal to 5 times 3 would give us a 15. And 5 times, this is a negative 1d. So be careful, we'll give us a minus 5d. Now, here's where you need to be careful. Whenever our letter is behind subtract, take the time to put your little plus sign there to help you remember that that negative goes with the 5 that's being multiplied with d, and we have to start with getting rid of that positive 15 part, so be careful. I'm going to cover the entire term, including the subtraction sign. I need to get rid of the add 15 or plus 15 part first, right? That's this add subtract part first, by subtracting a 15 from both sides. So negative 20, I need to subtract 15 from it. Adding and subtracting will never flip-flop the direction of our sign, so bring it on down. Over here, it might be helpful to put your subtract 15 right here so you see that those are actually going to cancel. If I put a plus 15 there, I would have 30. I want them to eliminate, not add more to what's already there. And then put your minus 5d. Now you say, yep, those do cancel. I did the right inverse operation. Bring down your greater than or equal to. Over here, we'd have a negative 35. And over here, we now have our negative 5d. All right, gone with this guy. We're now on our multiply, divide, and check for the flip, no flip rule. Since right now this is a multiply, our inverse operation is going to be to divide on both sides by negative 5. So we take our negative 35, we're dividing it by negative 5. This number, the one I'm dividing by, is my flip, no flip number. Since it's a negative, I also have to flip on this step. on this line right here, it should now be a less than or equal to, so be careful. What we do to one side, we got to do the other. So over here, we're going to also divide by -5. Cancel on the one side. Negative divided by negative over here is going to give us a +7 is less than or equal to D. All right, let's make our graph of our solution. 7 in the middle. 6 and 5 getting smaller. 8 and 9 getting bigger. All right, we're starting here at 7. Since it could be equal to 7, we know that from this little bar down here under the less than, then our circle needs to be closed in or shaded in to start. Since 7 is less than D, that means D is bigger than 7, which means we should be shading this way towards 8, 9, 10, 11, 12, so on until infinity. Now, if your gut was saying, oh, I should be shading left for this, then you need to, off to the side, get your letter in the front, number in the back, and do your flip-flopping to help you know, I should have been shading to the right. All right, these two things give me the same shade. Most of us like this version where the letter's in front better to help us, so be careful. All right, I hope that helps you attack your work for today. See you guys later.